Hey everyone, welcome to this episode of KuTube. Today we're going to be continuing our work on linear functions by exploring slope and slope-intercept form. So let's get started. Before we begin today, you're going to need a few materials. Make sure you have your notes printed out or set up a graph paper with the heading on top and today's date. We will be graphing today, so make sure you are using graph paper and you have a ruler readily available for you. You're going to need a pencil to do some math, and as we're doing some corrections today, you might want to use a pen so those mistakes and those corrections stand out to you. Alright, so let's get started. So today we are going to be talking about slope-intercept form, which is section 3.5 in your textbook. Today we have a few goals. Your goal is to be able to use the slope-intercept form to find the slope, the y-intercept, and to graph a line. Before we explore slope-intercept form, though, let's kind of talk about what slope is. So if you are following along with the guided notes, you're going to see there's a section for you to write down this definition. If not, please write down this definition right now. So what is slope? Well, slope is a ratio, and as we know, ratios can be written as a fraction. All right, so the slope is the ratio of the vertical change to our horizontal change between any 2 points on a line. There is an equation that represents slope, and I'm going to put that in a cloud right here. Please record this down in your notes. All right, to represent slope, we use this equation m equals y sub 2 minus y sub 1, in other words, our vertical change, over x sub 2 minus x sub 1, which is our horizontal change. You're going to notice that we use the variable m to represent slope. On the bottom of the page here, you're going to notice there's a few different ways that I have shown slope. You don't need to write these down, but I just wanted to show you that there are some ways that slope is represented in textbooks, on worksheets, by other teachers. So sometimes you might hear a teacher say slope is rise over run, right? Because we're looking at that vertical change going up and down over a horizontal change running going left and right. Sometimes you also might see this written in a textbook. This is just called delta y over delta x, which is just a fancy way of saying change in y over the change in x. Now that we know what slope is, let's actually apply it to some problems. The first examples we're going to look at is how to find slope given a graph. So in example A and B, I've given you a graph, and what I want you guys to do is describe the slope of the line, then find the slope. Well, if I take a look at this graph, what I could do, right, is use this formula. I know that if I have any 2 points on a line, I can plug it in, and I can easily find 2 points. I don't know about you, although using an equation would be great, right, using that formula for slope would be great, we have a visual here. So let's actually take a look at how we can find the slope of these graphs by just counting, all right, by using the visual. So the first thing I'm going to do is take a look at example A and describe the slope of the line. And the way I'm going to do that is take a look from left to right, my leftmost point to my rightmost point on the line. And I notice that this graph is decreasing. So I'm going to automatically say this is a negative slope. The next thing I'm going to do is I'm going to look for 2 specific points. In this case, I could use B and I could use point A, but point A is pretty far. So I'm going to use point B, and I'm going to look and kind of trace my eye along the graph to see the next perfect coordinate point. And instead of plugging into the formula, like I said before, we're going to count. We're going to look at the change in look at the vertical change, 1, 2, 3, 4, so it increased by 4. And then we're going to look at the horizontal change. And since it went left 3, we're going to do negative 3. So my slope here is 4 over negative 3. And as we know, we can express that in 3 different ways, right? Negative 4 thirds, negative 4 over 3. For the sake of this, we're going to typically write my slope with the negative in the numerator. Now, it actually doesn't matter where it belongs, all right? We know they're all equivalent, but I just don't want you to lose that negative sign in the fraction bar. So my slope, m equals negative 4 thirds. So now you know how to describe the slope of the line. You know how to count to find the slope. I want you to pause the video and try example B. All right, so hopefully you've described the slope and found the slope of example B. We should have noticed that this is a positive slope, right? If I start from the left of my graph and I notice that the line is increasing, so we have a positive slope. And my slope here is 3 over 2. For both of these examples, you're going to notice that I left them as improper fractions in simplest form, and that's on purpose. When we take a look at slope, remember it's a ratio. We want to leave it as a fraction. If we turn it into an improper fraction, it won't tell me that relationship between my horizontal change and my vertical change. All right? So keep your answers as an improper fraction in simplest form. Now that we know how to find slope from a graph, let's take a look at how we can find slope from a table. So the points represented by each table in example C and D lie on a line. So if I took all these coordinate points and graphed them, it would form a straight line. My goal here is to find the slope of each of these lines. Well, I can easily take these coordinate points in example C, and I can graph them, and then I can kind of use that same strategy that we just did here by counting up and over. I don't know about you, but I don't really feel like graphing these, right? That's really time consuming. So instead, we're going to use the formula. If we know 2 points on the line, we can use those 2 points to calculate slope. And remember, we used a variable m to represent slope. So we've got a table of multiple coordinate points. So I'm going to start by writing down my formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the first thing I need to do is choose any 2 coordinate points. And it actually doesn't matter which 2 coordinate points you choose. I'm going to choose 0, 3 and 1, 5. And I'm going to purposely put those over here and list them out. I'm choosing 0, 3 and 1, 5. I'm going to take the time to label these coordinate points with x sub 1, y sub 1, x sub 2, and y sub 2. All right, that's going to tell me the different points. And then I'm going to plug it into my formula. Y sub 2 is 5 minus y sub 1, which is 3, over x sub 2, which is 1, minus x sub 1, which is 0. 5 minus 3 is 2, 1 minus 0 is 1. So I get the slope, m equals 2. What this tells me is that if I were to take the time to plot all of these points in my my table here, it would form a linear function with a positive slope of 2. Now that we know how to find slope from a table, let's just kind of quickly go over some of my expectations. Anytime I'm asking you guys to calculate slope, given some coordinate points, I do want you to start off by writing the formula, identifying which points you chose. Now remember, I chose any 2 points. You could have chose 2 different points and still would have received the same solution. I want to see you evaluating that formula with your coordinate points, and then your final answer should be labeled with m to represent that that's the slope. My slope is 2. Now that you know how to find slope from a table, I want you guys to pause the video and try example D on your own. When you're ready, unpause the video and we'll look at the answer. Alright, so example D, you should have noticed that I started off with the formula. You're going to notice I used the points 4, 20 and 7, 14. You didn't need to do that, but if you did, great. No matter which 2 points you chose, you should have gotten the final solution of m equals negative 2. Once again, that means if I took all these coordinate points from this table and graphed that, it would give me a linear function with a negative slope of negative 2. Now that we know how to find slope from a graph, and we know how to find slope from a table, let's bring everything together, all right? There are 4 different types of slopes that we should feel really comfortable with moving forward. The first slope is a positive slope, and we can easily see on this graph, if we start from the left and go to the right on my graph that I just traced in purple, it's increasing, it's a positive slope. The next type of slope you might be familiar with is a negative slope. Right, if I start from the left on my graph and trace it, you're going to notice that line is decreasing, so I'm dealing with a negative slope. Now the last 2 are a little funky, right? In this third example, we've got a vertical line that crosses through my x-axis. So in this case, I would actually call this x equals negative 5. And in this case, this is an undefined slope, all right? The next example, we have a horizontal line that's crossing through y equals 5, and it's intersecting my y-axis here. This does have a slope, right? If I kind of imagine a person standing here and they're walking along this path, they're not moving up, they're not moving down. This ground has no slope. So we actually call this slope 0. It has a 0 slope. Now that we know the 4 different types of slope, we're going to now apply it for our next portion of our lesson. All right, so the next thing we're going to talk about is bringing everything together within our linear functions unit. So remember, we are in our linear functions unit, and we're looking at every graph that we're looking at will be a straight line. There are 3 different ways that we express linear functions. One of the ways is standard form, the other way is slope-intercept form, and the third way is point-slope form. By the end of this unit, we're going to be comfortable manipulating an equation in all 3 forms. For today's lesson, though, we're going to be focusing on slope-intercept form. So what's slope-intercept form? Well, slope-intercept form is just a specific way of writing a linear function. And the way we write that in slope-intercept form is y equals mx plus b. There are some variables that we need to point out. Every time we see the variable m, we know that represents slope. And every time we see the variable b, we know that represents my y-intercept, which seems a little funny, right? Like, why is b being represented by the y-intercept? Remember, y-intercept is the point at which a line crosses the y-axis. So if you look at this figure here, this function, this graph, is crossing the y-axis at this point, and that's the coordinate point that we would reference as my y-intercept. There are two other variables in slope-intercept form that I don't want to go overlooked. All right, we have the variable x and we have the variable y. Now, just like we've learned in the first half of our unit, that x still represents my input value, and this y still represents my output value. All right, so don't think that doesn't connect to what we've been learning. So now that we know what slope-intercept form is and that you've labeled, hopefully, this in your notes, let's actually talk about some different ways I might ask you to solve for slope-intercept form. So the first type of question I might ask you is to create an equation from a graph. So in this figure to the right here, you're going to notice a graph, and all I'm asking you guys to do is to write the equation for this graph in slope-intercept form. So let's think logically, right? If I'm asking you to write it in this form, y equals mx plus b, I'm going to ask myself, well, what two pieces of information do I need? Well, I need my m, which in other words is my slope, and I need the b, which is my y-intercept. So easy enough, right? I take a look at my graph and I say, well, what's my y-intercept? At what point does this graph cross my y-axis? And in here, I see my point is 0, 3. So since it's 0, 3, we say that my y-intercept is 3. The next thing we're going to have to do is determine the slope. Now I can sit here and choose 2-point values and plug it back into the formula for slope, but we've got a visual here, and like we've learned, we can count, right? So I look for any two coordinate points, I find the vertical change over the horizontal change, and now I found my slope is negative 2/3. And I always just double check, is this line actually, is it decreasing, is it negative? And it is. So now we're good to go. Once we found the slope and the y-intercept, we're going to replace those values in the slope-intercept form. So y equals, I'm replacing my m with negative 2/3 plus 2/3 x plus my y-intercept, which is my b value, which is 3. And that's it. We've now created an equation that represents this graph. I'm going to erase this. And we've written our equation in slope-intercept form. All right. So now that you guys know how to take an equation from a graph or write an equation from a graph, I want you guys to pause the video, try these two examples out, taking a look, can you find the slope, can you find the y-intercept, and the equation. Once you're ready, you can unpause the video and we'll go over the solutions. Awesome, so hopefully you're done. The first example, you're going to notice I have a positive slope of 2. My y-intercept is -1, or in other words, 0, -1. All right, so the equation in slope-intercept form is y equals 2x minus 1. That's the equation for this line right here. In my second example, you're going to notice the slope is -3/4. Shame on me, I should have put arrows at the end of this to show that it continues forever in both directions. My y-intercept is 5, or in other words, 0, 5. And my equation in slope-intercept form is y equals -3/4 x plus 5. All right, now that we know how to create an equation from a graph, another type of question I might ask you is to write an equation given a table. So in this example here, I'm asking you to take this table of values and write an equation that would represent this table of value in slope-intercept form. Well, once again, in slope-intercept form, I need two pieces of information, my slope and my y-intercept. So let's start with our slope. Sure, we can take all these values, we can graph it, and then kind of count up and over, but once again, we're trying to be efficient, right, with our time. To find slope, I'm going to start by using the formula for slope. Y sub 2 minus y sub 1, sorry, that was a little messy, over x sub 2 minus x sub 1. And in order to actually do this, we need to choose 2-point values. Now remember, it doesn't matter which 2-point values you choose. I'm purposely going to choose these 2 point values just because I think it's a little bit easier to deal with positives. It does not matter if you choose 2 negative values. Just be careful when you're plugging it in. Notice I'm labeling them so I don't make any silly errors. And now I'm going to plug it back into my formula. So y sub 2 is 3 minus y sub 1 is 1 over x sub 2, which is 1, minus x sub 1, which is 0. I simplify that 2 over 1. So in this case, my slope is 2. So we've got our slope done. Now we have to figure out our y-intercept. Now I take a look at my table of values and I'm going to say, is there a point in this table of values that represents my y-intercept? Good, you found it. My y-intercept is 0, 1. So in this case, I'm going to say my b is 1, right? Because we have that point 0, 1. My final step is to take those 2 pieces of information, my y-intercept, my slope, and plug it into the slope-intercept form. So y equals 2x plus 1. We have now created an equation that represents this table. Before we begin, I do want to just take a moment and really bring everything together for a moment and remind you that even though we keep replacing slope and y-intercept, there are 2 other variables here, my x and my y. Now if I take my x and I take these input values, I input -2, I should get a -3 as my output. If I input -1, I should get -1 as my output. So that idea that we learned in the first half of this unit should still apply. That x value in my equation represents all my input values on this table. So that's also a nice way of checking to make sure your equation is correct. All right, so we've learned how to create an equation from a graph. We've learned how to create an equation given a table. The last type of problem I want to talk about is, let's flip it a little bit, right? What if I give you an equation and now ask you to graph it? Now there are different ways to graph an equation, but today we're going to really practice graphing it in slope-intercept form. Now we're going to notice that the equation that was given here, that I'm going to highlight in yellow, unfortunately is not in slope-intercept form. So we're going to use what we know about literal equations to manipulate this and to solve for y. So we know the drill here. To solve for y, the first thing I'm going to do is subtract 3x. What am I left with? Good. 2y equals -3x minus 8. What do I do next? Good. Divide every term by 2. I'm left with y equals -3/2 x minus 4. Keep me in mind, we're simplifying everything. So once we've written my equation in slope-intercept form, let's pull out the important information we need. We're going to pull out my slope, which in this case is -3/2. We're going to pull out the y-intercept, which in this case is -4. And just to help myself, I'm going to write that coordinate point, right? If my y-intercept is -4, the point value is 0, -4. So to graph this equation, I'm going to start with my point 0, -4. The next thing I'm going to do is to use the slope, -3 over 2. Now I can't count down 3. It doesn't actually fit on this graph, as you guys can see. But we can reverse this, right? This is the same as saying 3 over -2. So instead I'm going to count up 3, 1, 2, 3, and over 2. Oops, I don't know why I just did that. So 1, 2, 3, and over to the left 2, 1, 2, and that's going to bring me to my next coordinate point. If you feel comfortable, you can connect these 2 points. I typically like to plot 3 or more points. 1, 2, 3, up 3, to the left 2, 1, 2. All right, and then once you're ready, take a straight edge, and you're going to draw a straight line to connect those points. Draw arrows at the end. So remember, the equation that represents this line is either of these, 3x plus 2y equals -8, or in slope-intercept form, y equals -3/2 x minus 4. But we just learned how to graph an equation. So remember, to graph an equation, the first thing we should do is to manipulate the equation into slope-intercept form, like we did here. Then we pull out the 2 pieces of information we need, the slope and the y-intercept. Start with your y-intercept, then count up and count over to graph the line. Now that you know how to graph an equation, go ahead, pause the video, and try these 2 examples out. All right, hopefully you had a chance to try these out. In example 1, you're going to notice that I have a negative slope, right? We pulled out that negative slope of -2/3. Ooh, I apologize. This is totally written wrong. This should say -2/3 x. All right. Sorry about that. That x should not be in the denominator. So I pull out my slope of negative 2/3. My y-intercept is negative 2. And that's my line that's graphed there. So making sure that you've plotted at least 3 points, you use a straight line, and you have arrows at the end. In the second example, it was a little harder. You had to manipulate the equation first to solve for y. You should have written it in slope-intercept form, y equals negative 2/3 x plus 3. We plotted my y-intercept, which was at 3, counted up and over, and we have an increasing line that looks like this. Make sure you have arrows at the end of everything. All right, now that we learned how to graph an equation, let's bring everything together. All right, in these 6 questions here, I'm asking you a really specific thing. I'm asking you to manipulate the equation to write them in slope-intercept form, and then I'd like you to identify the slope and the y-intercept. So go ahead and pause the video, and I want you to first manipulate the equation into slope-intercept form, then take the time to identify the slope and the y-intercept. When you're ready, unpause the video and we'll take a look. All right, so at this point, hopefully you've solved all 6 of these problems. Let's take a look at the answers. In the first one, you're going to notice that all I did was solve for y, and we got the final answer of y equals negative 5/4 x plus 3/4. I've got my slope, I've got my y-intercept, and I wrote it also as a coordinate point. All right, so if you need to, you can pause the video and take a look at my solutions. The only 2 funky ones are x equals 5 and y equals negative 10, and you're going to notice to help guide your thinking, I actually drew a visual here to the right to really express what that would look like visually. All right, so if you need to take a look at those 2, pause the video right now and check your solutions with the pen, making any corrections as you need. All right, we're almost done. I just wanted to end the video with one last challenge problem. So if you feel pretty confident with this, I would recommend pausing it, trying it out, and then when you're ready, you can unpause it and kind of listen to how we solve this. All right, so in this problem, I give you an equation, y equals 4kx minus 5, and I give you a slope, m equals 1/2. In this problem, I'm asking you guys to find the value of k so that if I graph the equation, it has the given slope, in this case, m equals 1/2. Now, I purposely highlighted k for you just so you didn't get alarmed by that. But if I kind of take a look here at y equals mx plus b, right, in slope-intercept form, what variable represents slope in slope-intercept form? Good, m. So let's take that same equation that we have up here, y equals 4kx minus 5, and let's take a look to see what do I have in replace of m. Well, in this case, don't you agree, 4k is in the replace of m? And my goal here is to have a slope of 1/2. So essentially, can't I take this 4k and say, I want 4k to equal 1/2. I want that expression right there to equal 1/2. Once you have that, well, from here, we're just solving algebraically, right? To solve for k, I need to get rid of that 4. I do not show my work like this, all right? That should be hideous. We should be cringing inside. Instead, to solve for k, I'm going to multiply both sides by my reciprocal, 1/4. That simplifies, and now I'm left with k is equal to 1/8. All right? So a little bit of a different problem, taking a little bit about what we know about slope-intercept form, and my final answer should be k equals 1/8. Were you able to do it yourself? If so, good job. All right, we did a lot in this video, so let's kind of go over everything we've talked about, and let's kind of take a moment to reflect. The first thing we talked about is what is slope. We learned how to find slope from a graph and how to find slope from a table. We also looked about the different types of slopes that we're going to deal with. We then introduced slope-intercept form, which is our first major form of linear functions. From slope-intercept form, we learned how to write an equation from a graph. We've learned how to write an equation given a table. And then we switched it, right? Given an equation, can you graph it? So take a moment and reflect on what material you feel really confident in and which ones you don't. But other than that, thank you so much for watching, and don't forget to like and subscribe. Thank you. Bye.